Welcome to the Purdy Spit, everyone. We are here, and to show you about where we are, we've got Highway 302 right there, and we're down on the beach with a lovely low tide happening in about an hour or so. And we're just checking in with Stina and her community science crew to figure out, like, what are you doing?
Woo-woo! We're doing some beach monitoring today. It's our first event of the summer season. We do this every summer and winter at, I think it's 11 different beaches.
Yeah, it's a lot. You guys have grown the program quite a lot.
Absolutely. And one of the things we're growing is looking at eelgrass. And so today I'm going to take a peek at some of that.
So first, anyone who's watching, feel free to post where you're watching from while we tell you about eelgrass.
Yeah. And so right now we're looking at the non-native species, Zostera japonica, or
Japanese eelgrass, I would guess.
And they have these really thin blades. And so something we're looking at is really, we want to look at the native eelgrass. And so this is going to be kind of boring data because there's all zeros on this transect.
But zeros are data, so that's good.
Too, but I think we're going to go ahead and count japonica for all intents and purposes today, because it's interesting how these eelgrass species may someday interact. And so having some quantitative and qualitative data on this stuff will be helpful to document changes over time. And so some things that we're going to count is we're going to look in this quarter meter quadrat, so a meter by half a meter, or no, not half a meter.
A quarter meter.
A quarter meter. That's the word. 0.25 by 0.25 makes this nice little area that we can then look in, and we can look at first kind of the percent cover of the seagrass. And I like to do some mental magic where you kind of clump all the grass and like fill in all the spaces of sand. So like if I were to move that, like I think it's almost like in the 50% range, maybe a little bit less than 50%, so 45-ish.
Yeah, I would agree with that.
And then another thing we're going to do is count the number of shoots, and that's going to be basically these little spots where the eelgrass pops out of the sand. And so we'll kind of go through counting all of those and record the number of shoots and the percent cover of this eelgrass.
The square, and then randomly along the line.
Randomly along the line.
We'll do some more. And tell us a bit about why eelgrass is important.
Yeah, so eelgrass is a crucial habitat.
Turn you this way.
It's kind of like think of the forest. It supports all sorts of different life. So this is like the mini forest of the intertidal zone. And so things lay their eggs. When the tide is high, I just wipe sand on my nose. Animals can hide in it from predators or find delicious food if you are a predator. So eelgrass is one of those key habitats that we're interested in the restoration of in the South Sound area. So yay, eelgrass.
It is important.
Has some really important environmental impacts. So it's a huge carbon sink. So because this is an actual plant, eelgrass is one of the true plants in the Puget Sound, whereas all that seaweed is its own category of life.
Yeah, so if we look at kind of the difference between these two, here we have some ulva sea lettuce that is, if I tear it, this piece can continue to survive and just keep on doing photosynthesis. But if the eelgrass gets broken, it's not going to survive that. It's like cutting a branch off of a tree. It's it's integrated. It has different tissues, and it is a true flowering plant. So it has roots and stems and leaves and flowers and seeds. Which is cool. And it also spreads by rhizomes, which is like runners. Just like in your yard, you've got grass that can spread and kind of outgrow your lawn area. You kind of have to keep edging it. Eelgrass does that too, which is something that we want to see. We want to see the spreading of it a little bit because it's so good. It also stabilizes the ground and prevents erosion. It minimizes the impact of the waves. Oh, and it's good habitat for this little tiny hermit crab in a much too large moon snail shell. Oh, you're adorable, little friend. Yeah, so there's lots and lots of benefits to this eelgrass, which is why we are studying it and trying to learn more about it.
I'm curious, so kind of looking at this this eelgrass versus if we go lower in the intertidal zone. So something that's kind of cool about the different eelgrass species is that that's a really high growing eelgrass, whereas our native eelgrass likes it a lot deeper. And so as we kind of walk out here, I assume we're going to start, well, you can still see the thin blades of Zostra japonica, and it's kind of murky.
The wind is out and about today, so stirring up sediment and creating a little bit of waves for us. Oh yeah, quite murky. We're gonna take your word for it that there's eelgrass out here, Stina, because I don't think we're gonna see it.
Yeah, the tide is still going out. We have about a negative 2.5.
Yeah, 2.5.
And so I
We'll
think
get
we'll see
plenty of eelgrass exposed today. Yeah.
So this makes me, so we're using the shoreline survey. So there's a WSU whole monitoring toolkit that we're basing this eelgrass research off of. And so that data can go to them. But they're interested in the native eelgrass, which I think because they're a more northern place,
yeah.
the protocol is a like 0-foot tidal height. But if we were to look at the 0-foot, there is no eelgrass in our south.
No native eelgrass.
Oh, yeah.
Or yeah, I mean
no
even
eelgrass at all.
Yeah.
We were just at the -1 because
the tide's
we can have some good zeros in that tidal height, but look, let's actually count some eelgrass for the sake of this.
so that we know it's recorded when the eelgrass starts in the tidal zonation. That's, I mean, good information to have too. But yeah, it'll be interesting to compare the south sound data to the north sound data.
But I think logistically we'll just need to use different tidal heights because our eelgrass shows up in different spots. It's fascinating.
Yeah. And speaking of non-native species, we've got a non-native seaweed here. This is called sargassum or wireweed, and it is different from a lot of our native seaweeds because it has these little floats, these little pneumatocysts. They're filled with gas, and that helps keep this suspended in the water column. And this is a favorite place for animals to lay eggs. So we've got this yellow blob. Those are the eggs of a bubble snail, which is a type of sea sluggy. Yeah, the adults are much harder to spot than their eggs. The eggs kind of stand out. Here's also, you probably can't see them. They're so tiny. Just itty bitty little eggs on there too, of some animal I don't know. It's very difficult when all the eggs look the same on the beach.
And I just kind of want to throw out that even though like the seaweed's non-native, the eelgrass is non-native, like they have been around for a long time. So at this point, they still serve as really valuable habitat.
Yes.
So a good
it would be better to have them than to not.
Yeah, a good tip for kind of walking through eelgrass is don't.
Yep.
If you can avoid walking across an eelgrass meadow, definitely take the path around through the sand. But if you do have to cross through or you see a cool creature you want to check out, just those gentle steps, like don't do a lot of swishing and swashing because that will disrupt the rhizome connections that eelgrass uses to stay put. And so just, slow, gentle feet across the eelgrass bed. Also because you don't know who's living under that eelgrass.
Yes, a lot of animals will hide underneath the grass to withstand drying out during the low tide. And so it's a very horrible feeling when you feel that crunch that you weren't expecting. And likewise, if you are harvesting shellfish, there are not going to be very many clams or oysters in the eelgrass bed. And so this is not a great place to dig. So you want to avoid that as well. So yeah, any last thoughts about eelgrass before I go
I think
finding some more
Purdy
creatures?
Sandspit is just in general a really cool place to see kind of where these two species of eelgrass are going to come together. Granted, we didn't actually see the native eelgrass yet.
It's there. It's just right off there.
But I have a feeling we're going to do a fish seine later today, and it's really fun to see what kind of fish are living in the eelgrass when the tide is high. So the fish just kind of make their way out, hiding in that eelgrass as the tide goes out, and then they'll come back into this habitat when the tide returns. So
Yeah. And some of my favorite eelgrass beds to visit locally, there is a good chunk out at Sunrise Beach, which is a marine preserve, which is part of the reason why that eelgrass is thriving there. It's a no fishing, no harvesting of shellfish. Also Titlow Beach, which is also a marine preserve as well. And then down in Stilcombe, Sunnyside Beach Park is a really nice place to go and walk and see the eelgrass beds. So if you're looking for an adventure to get out and explore the low tides this week, you can visit and appreciate this super cool, amazing plant.
And I want to note that since it's still early in the warm weather season, just looking at the eelgrass, you'll notice it's very pristine. It's looking real good. There's definitely a lot of epiphytic types of algae that will grow on the blades, and so it starts looking really scuzzy later in the year.
It does.
So,
and it traps a lot of sediment and gets really muckier than it is right now. It's pretty clean.
If you want to see really good looking eelgrass,
now is the time.
The better.
I love it. Well, I think I'm going to walk along a little bit and find some creatures living amongst this eelgrass. I'm going to let you return to your science because your team over there could probably use you.
Yeah.
At least, keep them on task.
But also just a shout out for some incredible, senselessly low tides this week. Go play on the beach. Or of course, tune in with us. So.
Yeah, now through Sunday we've got low tides during the day.
We'll be doing science on the beach all the way through, so you can tune in tomorrow and see what we're up to.
Totally.
We'll have time, so.
Well, thank you, Sina. I'm gonna head down the beach. Again, if you're just joining us and you want to post where you're watching from, that is always fun information for us to have. We like to know how far our reach is going as well. Oh, I found a creature already. So this is a heart cockle, and we're going to watch them just bury themselves down into the sand. Heart cockles are one of the few clams that does not go very deep. So they can bury a little bit. They use their muscular foot to kind of squish a hole into the sand, and then they pull themselves down. But we'll probably see some larger cockle shells that have been opened and on the beach, and we might stumble across the live clam as well. So this one's just a juvenile, and they are vulnerable to gulls at this size. So here's your scale. This is a pretty small creature right now, and they can feel the vibrations of me walking on the sand, as well as maybe sense the change in the shadows too. It seemed like when I got close. Yeah, look at that. So they're heading down into the sand to be protected, because of course clams are delicious, right? Not to me. I don't eat my coworkers. I feel like I have such a relationship with these animals. I don't want to eat them. But if that's you, just make sustainable seafood choices and you'll be on the right track. I always recommend people get the Seafood Watch app, which is a really great program that is put on by the Monterey Bay Aquarium, and they do a bunch of research and work with different entities and scientists to determine which fisheries and which seafood is sustainable. So download that app if you've got a smartphone. If not, you can also check out their website, seafoodwatch.org, and it'll help you make responsible decisions that help benefit our oceans and estuaries. So what we're looking at right here is one of the signs that there is a moon snail present in this environment. This is the egg case of the Lewis's moon snail, and this is made out of sand and mucus, so it's very smooth. It has this kind of rubbery texture to it, and I always like to look underneath them because sometimes you'll get other snails, like these little dove snails, hanging out with them. Sometimes you'll see baby sea stars, or sometimes animals will lay their eggs on these egg cases because this is not very palatable. There's nothing that really eats this. And so these eggs, there's about 500,000 of them, are protected. As the eggs mature, the sand color will break down, and so we'll start to see these kind of crumbling as the tide goes in and out. But the eggs are in this thin layer right in between. It's like an egg sandwich almost. And then that whole thing is extruded out. And here's another one. And because we're getting into the springtime, we'll start to see more and more of these on the beach. So it's one of the number one questions we get asked is, what are those weird gaskets, or what are those plunger things on the beach? And those are the eggs of the moon snail. We're probably going to see some other signs of moon snails as we walk along as the tide goes lower. But there are some other sure signs that it is springtime here at the beach, because I see this. Now, this is not a dead crab. This is the molt of a graceful crab. And you can see that the shell opens. This is just the outer coating, the outer armor of these arthropods, and they have to shed just like all bugs do. So everything that's got this harder outer shell, they can't grow this. And so what they'll do is they'll unzip it from the inside. There's a little seam that runs along there, and then the whole crab will pull out of this like a hand coming out of a glove. And they take everything with them. So even like the tips of these little pinchers all the way down to the points of those toes is going to come out. And then the crab is squishy and soft for about 3 days or so, until they can pull enough calcium from the water around them to harden their shell. And then they kind of carry on being a crab. So a lot of times in the springtime, when there is abundance of sunshine, there's lots of food, is when the crabs are molting like this. So the other way to tell if it's a molt or a dead crab is by smell. So a molt has no smell at all. It's just gonna smell like just the air. But a dead crab is gonna stink. So this, I would guess, is a dead crab, but we can take a look and see. Oh yeah, so see those snails on it? These are dove snails, and they are scavengers. So they eat just about anything that they can find, especially dead things. They have this nose, this proboscis that sticks up, that can sniff out really stinky stuff from quite a distance away. Oh, I got all excited for a second thinking I found a ribbon worm, but instead I have found a ribbon. So we will take this off the beach. Somebody's maybe floral arrangement, chopstick. What are we looking at here? I don't know what it is, but it doesn't belong on the beach, so we'll take that trash with us. That's a really good tip for anytime you're visiting a natural space. If you can either leave no trace or leave it better than you found it, that will ensure that our wild spaces are taken care of somewhat. So more moon snail egg collars. And once these are laid, the snail just kind of leaves them. They don't guard them or anything like that. They're left on their own. And a lot of the invertebrates, oh, you see that gull over there? The gull has a cockle. So one of those clams like we saw earlier, that's a quite big one. And gulls are quite crafty. They have figured out that if they fly up high over the rocks or the road, they can drop it, and that will break open the shell of the clam, and then they can eat the meal inside. So a lot of rooftops around the Salish Sea are covered in shell debris from those gulls and crows that do that. So here we've got a little bit smaller moon snail case. Ooh, and so what we're looking at here, this is a puddle. It's not a true tide pool. This is left behind by clammers who didn't quite properly fill their holes, but it's giving us a little opportunity to watch our graceful crab here in action. This is the same species as that molt we saw a moment ago. Looking a little crabby, my friend. Notice those pinchers went up, and it's trying to be kind of big, posturing to us. It's all for show though. Graceful crabs are one of the most docile of all the crab species out there. They're one that I don't really hesitate to handle. But we'll leave this one in this puddle because he seems to be doing okay. There's a few more smaller crabs in there. And I apologize for the wind and the glare. Two things I really can't control too much. Got a different crab species I'm noticing here on the run, who's also gonna posture to us. This is what oh, you are the crabbiest of all the crab species. This is a red rock crab, Cancer productus, and they have that very typical crab shape. Huge pinchers in the front that when fully grown are capable of snapping a pencil. And this is quite an aggressive individual. And this one looks freshly molted. Its shell is nice and hard though. So I can show you that this is a boy crab. See that little triangle in the center? That's their abdominal flap. A female crab will have a really large one, whereas the male is a very skinny one. And that's because the females have to carry thousands and thousands of eggs, and the males don't. So they don't have the same adaptation for that. But you'll notice the crabs move sideways. Their jointed legs are jointed on the sides. And when he can't bluff his way into getting me to leave him, he's gonna show off the other amazing adaptation that crabs have, and that is that they can dig themselves down in the sediment and soil. So this crab is using all of his back legs to kind of stir up and loosen up the sand, and then he uses his pinchers to push himself backwards. And then you'll notice that all of the sensory organs, the antenna and the eyeballs, as well as the mouthpieces, are all right there up front. And that's a really great adaptation. If you need to bury yourself in the sand, you can still survive and still be aware of what's around you. Nice, good to see. We'll leave him be. He's probably gonna just sit there and wait the tide out. So again, I'm being very, very careful as I walk through these eelgrass beds. Not stepping on the grass itself if I can help it. Here's some more signs of moon snails. This is an empty moon snail shell. Ooh, one that's been buried in the sand for a while. See that black line on it? That is anaerobic bacteria that lives in the very kind of silty sediment that doesn't get a lot of oxygen. And it stinks. That is what you smell when you smell kind of that low tide smell. And you can kind of see the blackness in the sediment here. Blech, stinky. That's, I guess, one good thing about these digital programs is you don't have to suffer through the smells of the beach. Although sometimes they're kind of cool. Like we might come across leather sea star and they smell like garlic for whatever reason. So I'm looking out and I see this. We've kind of gotten away from some of the eelgrass, but way over in the distance there's a good deal more of it. But we're in kind of tube worm territory now. Can you see all the little tiny little sticks poking up? These are tube worms, and the worm makes the tube around themselves as they're buried down in the sand, and that protects them from predators and also helps get their siphons, not really true siphons, but gets the place where their feeding tentacles are going to be away from where the sediment is. So even just an inch or two is enough to stop the worm from eating sand and allow them to eat the plankton that they want to be eating, which is good. So like Stina mentioned, we have a whole week of really great, very low daytime low tides. But we have low tides every single day. So here in the Pacific Northwest, we get 2 high tides and 2 low tides every day, and they're differing heights. And so you'll have like a really low tide and then a really high tide and then a medium low and then a medium high, and it just sort of oscillates between those forever. Oh, here's an interesting thing. Oh, 2 interesting things. Okay, well, we're gonna talk about you first. We got a kelp crab here. One that is missing some of their walking legs. This is an older individual, even though it's fairly small, and I can tell because it's been in that shell for a long time. So it's got debris on it, it's looking kind of scuzzy, and she's just crawling along, hoping I don't notice her. But the thing I wanted to show you that was kind of weird and cool, a dead flounder. I'm not gonna touch it, because I guarantee that is super stinky. But death happens, of course, it's a part of life. Just like the cycle of the tides going in and out, we have the cycle of life and death. And springtime is really the season for rebirth, and lots of the creatures in the intertidal zone are going to be reproducing. So here's another moon snail shell, as well as this great algae here. This one has lots of names, but my favorite is red spaghetti or sea noodles. Oh, here's some evidence of a moon snail. This is a clam with a perfectly round hole in it, and that is where the moon snail has licked its way through their shell. They use a tongue called a radula that is like a chainsaw, and it just scrapes and scrapes and scrapes straight through this hard shell where the clam's muscle is that holds them closed, and then they can eat them. So a lot of people don't like moon snails on their beaches because they're in competition with us if you're a clam eater, but the moon snail egg cases that you see are all going to have tons and tons and tons of larvae, 500,000 eggs in each one, and that's going to help feed the clams and bolster their population as well. So we're coming up to another eelgrass bed, and I'm going to actually cross over. It's very shallow here, just barely over the tops of my boots. And this beach goes out a long, long, long way. But now we're in, okay, so we've got both kinds of eelgrass here. This is the japonica, Zostera japonica. This is our non-native species. And then just right here, we can see the difference in the size of our native eelgrass. So much thicker blades. And this is kind of a small patch. It's just getting going, but they can get like 3 feet long. And there's a lot more of it now that we're in these lower tidal heights. So the lower you go, the more eelgrass you will find. And then there is a point where it gets too deep for eelgrass to grow. And that happens because the eelgrass is doing photosynthesis. Ooh, another graceful crab. Hi, cutie. They need the sunlight to be able to make the sugars to grow. And once they get too deep in the water, oh, you guys. Okay, let me finish my thought. First, there's like a whole graceful crab jamboree here. And they really love this habitat. This eelgrass habitat is perfect for them. They're all kind of hanging about. But I see more evidence of a moon snail. Oh, and a tidefish. You can see that that's a little baby tidal sculpin, I think. That's my finger. So we're talking itty bitty. But right here is a moon snail. And all I see is that little tiny bit of shell, but it's oriented in the right direction for this to be a live moon snail. And the shell's pretty clean underneath all that sand. So I'm gonna just do a quick excavation here. Let's see if it is indeed a moon snail. Oh yes, here we go. So we've got a beautiful snail. Finding moon snails is, I believe, like my best special talent. Like, yes, I can talk to people, that's fine. Yeah, I'm an okay artist, sure, I can write decently, but no, finding moon snails is like top of my resume. So great to see. So this is a huge snail. This one is not nearly fully grown. And for size reference, they can get nearly as big as maybe a softball for their shell, and then the foot, the slimy, muscular foot, gets as large as a dinner plate. And I think the oldest one I've ever seen was 16 years old, and you can tell that by examining the shell. So they lay down a growth line each kind of in the winter time when they're not growing very much. You can kind of see there's a line right there. Looks like maybe there's a line right here, hard to say. Sometimes they will have breakages in their shell too, like here, it's a little spot where the shell got damaged at one point. They're incredible diggers. The snail's just been, unearthed a minute ago, and already is using that super foot to squish, using their mucus to reduce the friction and then they're gonna just push themselves back down and underneath. So being buried really is their strategies to success. But there comes a point when the moon snails are big enough that they don't really have to bury themselves any longer. And so sometimes you'll just find huge moon snails right on the surface because a seagull is not strong enough to pick them up. If they get really threatened, they can go in. Here's another moon snail. This one's a little more obvious because there's the ground is mounded up. See that? And I can see this little curl in the snail's foot, and that is allowing them to pull water over their gills very efficiently without being like smothered in the sediment. So I can show you that there is a moon snail in here. Oh yeah, here we go. There's a nice big one. So we don't have to pull this one all the way out. Ooh, maybe we do. That's a huge one. All right, we're gonna pull it out just so you can see the size difference between this one and the other one, who's already buried, by the way. So I'm just gonna gently pull. You can hear the suction. Slurp. Oh my, there you are, my beautiful snaily friend. That's a huge moon snail. So a little bit bigger than the other one. A great find here in this eelgrass bed. They're of course crawling along, finding clams. The smaller clam species like the eelgrass bed, so maybe bent-nosed clams, maybe some little macomas. So great to see. All right, and sorry I disturbed you, my friend. Well, actually, let me see. Sometimes you can just reach down in their little hole and feel for a clam, but I think you were just cruising, or you were headed this direction, so I'll let you head right back down there. But so nice to see such a big predator active and foraging in this habitat. And just while I've done that, I was right at the water's edge, and now I'm standing quite a bit away from the shore. So the tide is always moving. It's a great kind of fun science observation to bring kids to the beach. You can have them, draw a line in the sand and see if they can tell if the tide's going in or coming out. And then it's always great to talk about the adaptations that animals have for surviving this, because this is natural for them. This happens every day. Super great. Nice gull. I often will watch the gulls because they're very good at finding things. They have excellent vision. And of course they can fly quickly over the beach and just scan down. Here's another moon snail. See that kind of little siphon type shape? That kind of happens between the front of their foot and the back of their foot. Here's a cockle shell. So cockles are not often eaten by moon snails, but occasionally they are. This is called the heart cockle, because you can see that little heart shape. Love it. I always call this the potato chip clam because it's got ridges. Maybe if you're old enough, you remember those commercials that ruffles have ridges. Okay, now be really careful where I step, because now I'm in our native eelgrass habitat. You can see the thick blades, and notice they stand up quite a bit taller than the Japanese or the Japonica eelgrass. And here they are growing right together. So this is kind of what Stina and her team are looking at and trying to understand more. What kind of competition is happening here between this thinner non-native species and our native species growing right together. So this is where our beach monitoring community science efforts can help us understand more about this. And it gives us kind of a snapshot picture that we can look back on in time. And as we're living through this time of climate change, a lot of scientists are in this big hurry to kind of understand how things work, because as our climate warms and we see changes to our climate, our species are going to adapt to that. All right, my friends. Well, I've walked quite a distance away from my team, so I think I probably ought to head back. But thanks for tuning in with me today. I encourage you all to get out and explore and ask questions along the beach. Just remember to be a good guest in that habitat. Tread lightly, leave no trace, make the beach better than you found it, and just appreciate and respect all the incredible animals that have adapted to this amazingly challenging and wonderfully beautiful habitat here in the Salish Sea. So thank you for tuning in with us. We will be coming at you live for about the next 5 days, I think. You can check our events calendar for more information about that, or simply check your tide charts. Thanks, everybody. Appreciate it. Thanks for everyone who's liked and shared and commented on our videos. That helps, as well as those of you who donate financially to our organization. So you can do that through Facebook right here on your page, or you can make a secure tax-deductible donation on our website, harborwildwatch.org.